morning. In today's video, we will be seeing some applications of section formula. So let's begin. Let us say we have in the question a segment AB where A is minus 5, 8 and B is 1, 5. And the question says that this segment AB have 2 points of trisection. In other words, there are 2 points which are dividing this segment AB into 3 equal parts, and we are supposed to find the coordinates of these 2 points. Then how to find these 2 points using our section formula. So let us say first I assume some coordinates for this. Now as you can see, this point X has one part of the segment on the left hand side and 2 parts on the right hand side. That means this part or first part M is 1 and N is 2. That means the ratio in which this point X is dividing segment AB is 1:2. So now we know the ratios. We know x1, y1 and x2, y2. Using the section formula, we can definitely find the first point. So let us begin first. Now the formula is mx2 plus nx1 upon m plus n. my2 plus ny1 upon m plus n. Let us substitute the values. Now m value is 1 into x2 is 1 plus 2 into minus 5 upon 1 plus 2. Again 1 into 5 plus 2 into 8 upon 1 plus 2. Now when you will open the bracket, 1 into 1 is 1, 2 into minus 5 is minus 10, 1 plus 2 is 3, 5 plus 16 upon 3, 1 minus 10 is minus 9 upon 3 and 21 upon 3. So on cancelling, what we get is minus 3 and 7. So we got the coordinates of X as minus 3 and 7. So the first part of the question, that is the first point, is over. Now let us look at the second point, which is Y. Now to find out Y, there are 2 different methods. I'll just explain both the methods. Now let us say this is AB and this was point X and point Y. Now for point Y, you can see there are 2 parts on the left hand side. So M is equal to 2 and N is equal to 1. So the ratio has changed. For X point, there was only 1 part on the left. So M was 1 and there were 2 parts on the right. So N was 2. But for point Y, there are 2 parts on the left. So M has become 2 and N has become 1. So again using the section formula, we can find out the coordinates of the point Y. Here the ratio becomes 2 and 1. So let us again write the formula. mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n. So again let's substitute the value. 2 into 1 plus 1 into minus 5 upon 2 plus 1. Again 2 into 5 plus 1 into 8 upon 2 plus 1. So now what we have is 2 minus 5 upon 3, 10 plus 8 upon 3. So this is minus 3 upon 3 and 18 upon 3. So now on cancellation, what we get is minus 1 and 6. So we got the Y coordinate also. Now this is one method. Now the second method which I am explaining here is, let us say I have this as AB and this was my X and this was Y. Now I got the coordinates of X as minus 3, 7. I know B, which was already given as 1 and 5. Now can you see this? If I ignore the point A and I just look at X, Y and B, can you see this Y is having one part on the left till X and one part till B. That means in other words, Y is becoming the midpoint of XB. You can see this is one part, this is one part. So Y is the midpoint. So if I know X, if I know B, not necessary that every time I should use the section formula. By using the midpoint formula also I can get the answer for Y. Let us check out. Y midpoint formula is x1 plus x2 upon 2, y1 plus y2 upon 2. Now what is the value of x1? Minus 3. plus 1 from here upon 2. Then 7 plus 5 upon 2. So what we get is minus 2 upon 2 and 12 upon 2, which is nothing but minus 1 and 6. So you can see here I got minus 1 and 6 here also, and I got minus 1 and 6 here also. I'm getting the same answer whether I use the section formula or whether I use the midpoint formula. So it's not always necessary that we have to use the section formula. If the points are such that we can use the midpoint formula, we can definitely use that also. So let me show you one example where there will be no need to use a section formula, and just using midpoint formula we will be able to find out all the points. So let us say I have again a segment AN where A is minus 2 and minus 6, N is 10, 14, and now the question says is that this segment is getting divided into 4 equal parts. Now to divide into 4 equal parts, you can see we require 3 points. Then only you can have 1, 2, 3 and 4 parts. So let us say I have X, Y and Z. These are the 3 points which I require to find out. Okay. Now here you can see, now in this case, if I start with X, you can see this is only one part, and on the right hand side 1, 2 and 3. There are 3 parts. So using section formula, I can find out X first using the ratio 1:3. Okay. Or in other words, if you will look at point Y, can you see there are 2 parts on the left hand side and 2 parts on the right hand side? That means Y is becoming the midpoint of AN. It has got equal parts on both the sides, right? 2 on this side, 2 on this side. So instead of finding out X first, I can find out Y also first, right? So let us say if I find out Y first using X1 plus X2 upon 2, Y1 plus Y2 upon 2. So what I get is minus 2 plus 10 upon 2 and minus 6 plus 14 upon 2. So what I have is 8 upon 2, and this also will be 8 upon 2. So the answer that I get is 4, 4. So I got my Y as 4, 4. Right. Now you can see once I get Y and I know A. Now you see it becomes easier. Y is known. Don't look at the remaining segment. Now look at this. Y and A is given. And now you can see X is the midpoint of A and Y. So using A and Y, I can find out X again using the midpoint formula, right? We can just cover up this part so that we can understand. Let us say I'm covering this part up. Now my segment is AY and X is the midpoint. So I want to find out X, so I can just use A and Y. So again using X as the midpoint formula, now here instead of using A and N, I will be using A and Y. Why do I use A and Y? Because X is the midpoint of A and Y. So I should be using these two. So minus 2 plus 4 upon 2. Then minus 6 plus 4 upon 2. So what I get here is 2 upon 2 and minus 2 upon 2. So the answer that I get is 1, minus 1. So I got X also 1, minus 1. Now similarly, look at these two. I know the value of Y. I know the value of N. And you can see Z is the midpoint, one part on both the sides. So again using the midpoint formula, I can find out Z. So Z again will be X1 plus X2 upon 2, Y1 plus Y2 upon 2. So now I will be using Y and N because Z is the midpoint of YN. So 4 plus 10 upon 2 and 4 plus 14 upon 2. So what I get is 4 plus 10 is 14, 14 upon 2, and 14 plus 4 is 18 upon 2. So the answer that I get is 7, 9. So now I got my Z also 7, 9. So you can see in this question where there was odd number of points, 3 number of points, right? It is always easy to locate a midpoint. And once you get a midpoint, you can find out all the other points using the midpoint formula. And the calculation becomes easier because we do not have to use the section formula. Section formula becomes a little lengthier process, whereas midpoint formula is easy to calculate and very quick to get the answer. So this was one application of section formula, that is, you can find the coordinates of all the points that are dividing a particular segment in given parts. Now given parts can be 3, 4, 5, 6, etc. Depending upon that, we decide how many points are to be found out, and then we calculate whether we can use, as you can see, when the points are even, that is, as you can see in this earlier case we had, there were 2 points, even number of points. So it will not be easy to find a midpoint. We will have to first find out any one point using section formula, and then maybe we can find out the other points by using the midpoint formula. For example, let us say if we have a segment here, MN, and if I take even number of points, 1, 2, 3 and 4, right, you can see we will never have one clear-cut midpoint. Here you can see this is one part and 4 parts on the right. Here 2 and 3. This side 3 and 2. And then again 4 and 1. So you can see we will never have equal number of parts. But once, let us say, you find out this point using the section formula. Now you can see between these two, this point has 1, 2 parts, 1, 2 parts. So this becomes the midpoint of these two. So once you get one point, you can definitely use the midpoint to get this. Once you have this, you know these 2 points, this is the midpoint. You know this and this is the midpoint, right? So after you get 1 point using the section formula, the remaining can be found out using the midpoint formula. So this is how you find out the coordinates of the points that are dividing the given segment in some given parts. Now let us say another example. We have to see application of the section formula and the midpoint formula. Now in a triangle ABC, let us say I have D as the midpoint of side BC and a segment AD. Now you know this segment AD is called a median, and the point where all the 3 medians in a triangle meet is called a centroid, which is denoted by the letter G. And you know this centroid divides the median in the ratio 2:1. Now if all the 3 given vertices of the triangle are there, we are supposed to find the coordinates of this centroid G. So let us say A is x1, y1, B is x2, y2 and C is x3, y3. Now we have to find out the coordinates of this point G, right? Now you can see this segment AD is a segment where A is given, D we will have to find out, and the ratio is given 2:1. Then using the section formula, we can find out the coordinates of G. Now you know D is the midpoint of BC. So what will be the coordinates of D using the midpoint formula will be nothing but x2, that is this, plus x3 upon 2 and y2 plus y3 upon 2, right? That is what is the midpoint formula, x1 plus x2 upon 2, y1 plus y2 upon 2. So here x1 is nothing but x2 and x2 is nothing but y3. So addition of these two x coordinates divided by 2. Addition of the two y coordinates divided by 2. So now this has become my coordinate of D. Now I know A, I know D, I know the ratio 2:1. I can find out G. So G will be nothing but, again using the section formula, M. M is 2 multiplied by D, that is x2 plus x3 upon 2. Next, N, 1 into x1 upon 2 plus 1. Similarly, 2 into y2. y2 will be y2 plus y3 upon 2 and 1 into y1 upon 3. So this 2 can get cancelled, right? So what remains is nothing but x2 plus x3 plus x1 upon 3, y2 plus y3 plus y1 upon 3. We just rearrange it so it becomes easier to remember. x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. So this is the formula to find out the coordinates of a centroid. How did we get this formula? By using the midpoint and the section formula. So let's say I have an example. I have a triangle x, y, z where x is 5, minus 3, y is 3, 5 and z is minus 1, 1, 1. Now the question is, find the coordinates of the centroid G, right? So let us say this is my median XD and G is a centroid. So directly we can use the formula which we just now derived, x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. Now this is my x1 y1, this is x2 y2, and this is x3 y3. So what is x1? x1 value is 5, x2 is 3, and x3 is minus 1 upon 3. Next, y1 is minus 3, y2 is 5, and y3 is 1. So 5 plus 3 is 8, 8 minus 1 is 7, 7 upon 3. Here 5 plus 1 is 6, 6 minus 3 is 3 upon 3. So the answer that I get is 7 upon 3, comma 1. So this becomes the coordinate of the centroid. So you see, if all the three vertices are given, using the formula x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3 will give us the answer. Where what is this x1, x2, x3 and all? These are the three vertices of the triangle, x1, y1, x2, y2 and x3, y3. And how did we get this formula? By first calculating the D. This was just a derivation formula, how to get the formula, right? More important is the application, how you apply it to get the answer or to get the coordinates of the centroid, right? Okay. So these are the two applications of the section formula. Thank you.